Hey everybody, this is Larry. This is day 19 of the Leetcode Daily Challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about today's poem. We have a medium today, so that's good. I don't know, my sleep schedule is all screwed up because over the training and it's snowing, it's messy, so we'll see how it goes. But today, let's just focus on Leetcode. Let's just focus on, or not even today, just for this next couple of minutes, hopefully, not too long. Hope everyone's doing something to celebrate the memory of Martin Luther King. At least in the States. I mean, I guess if you're not in the US, maybe you don't. I don't know. Let me know in the comments. I don't know if like this. I don't know if he's like an important figure outside of the US, because obviously I'm very US centric, just because I don't know, right? But yeah, let me know in the comments. But anyway, today let's take a look. We have 1292, maximum side length of a square with sum less than or equal to threshold, which is of course what I'm going to name my first kid. These titles are ridiculous, but okay. Anyway, so you're given a matrix, a threshold, return the maximum side length of a square with a sum less than or equal to the threshold, or you return 0. Okay, so basically there's a 2 by 2. A 2 by 2 is less than 4. Wait, what? Isn't 4 once exactly 4, not less than 4? Man, these poems, these poems act like if they give you an example that actually explains the problem, they'll give it away the problem. Like I think I get annoyed sometimes about this. It's like, okay, like they try to I mean, this isn't a contest, so obviously this is a daily problem, but they try to make the problem sometimes like a reading thing where like, oh, gotcha, you misreading it. It's like, no, I'm here to solve problems, not here to read your poorly written English with the little gotchas. Okay, what is going on? The maximum side length of a square with sum less than 4 is 2 as shown. Why? It's 4, right? Less than or equal to threshold. But okay, I see. So the description is correct, but the example is kind of wrong. Okay. Anyway, the links are here, 300-ish. I mean, this screams binary search, but yeah, I mean, did we do this problem yesterday? A similar problem, or is that yesterday's the diagonal one, or was that during? Because I did a lot of contest videos yesterday, right? So I don't know where I saw it from. Okay, so yesterday, I mean, that's why I kind of hesitate, because I was like, isn't that just like exactly the same thing? Right? I mean, it's easier even, right? Because you just get a prefix thing, and then you get an O of 1. So it's going to be 300 cube, which I don't know if that's enough, but 27 million, but not all of them are doable. So, Well, yeah, I mean, it's not 200 cube. I already gave the answer, right? Which is binary search. If you binary search, then you don't have to do 300 times 200 times 300. It's just log of 300, which is fast enough. So let's do it that way then, right? Yeah. I'm like blanking out here, but. And this is just standard prefix sum e things, right? Oops. What? Yeah. I like to make it one indexed in a way. I mean, it's not really one index. It's just that there's an extra 0 at the end. Because I don't know. That's just the way I've always liked it. And you could write this in a number of ways. Something like this, right? Then now we have binary search. Left is equal to, I guess, 0, whatever. Right is equal to 300, or min of RC plus 1 to be inclusive. Right? And this is, you know, standard binary search stuff. And yeah, I was going to just write it in line, but that's even right here, right? So if this is good, then we know that this is now the new lower bound, and then we try something bigger, right? Otherwise, it's not good, then, you know, yeah. And then that's really it. Of course, now we have target, right? And then now we just start from something like this. I'm trying to think whether it's +1 or not, because if it's 0, then I always mess that up. I don't know. Okay, so if target is 1, it's gonna be R minus 1, and no, this is +1. Yeah. Because if target is 1, then it goes, yeah, okay. I think that's right, maybe. Right, so then now we just get the sum of the square, which I guess this is a daily video. I'll slow down a little bit. The idea behind these prefix sum, and this is something that you really should get to be familiar with. You know, there's the traditional 1D, if I could find my traditional pen. Sorry for technical difficulties. Okay, so the traditional 1D thing, right? And I always like to draw these things out. I mean, I don't draw it for myself that much anymore, to be frank, because I have a lot of practice, and the visualization's in my head, right? Because I have a lot of practice. But you know, you can draw it out like if 1D array. If you want to get like a sub array, then you just kind of visually see that what you're doing is you're taking this, subtracting from this to get this sub array, right? And in a similar way, the 2D matrix is going to look something like, you know, you have something like this, and you're trying to get, you know, like a sub matrix of this. Then you know, just draw it out, right? So you have this thing, you know, minus this thing, minus this thing, and then now you minus, you minus here twice, so then you add this back in, and that's really it. You know, it's all geometry, which is why I put a lot of emphasis on visualization. And once you kind of have this visualization, right, then, you know, just figure out the index is fine. Like maybe I mean, maybe sometimes I still have off by 1s, but you know, that's besides the point. Okay. And just to be clear, this one can be binary search versus yesterday's, or maybe the day before. No, yesterday's is magic square, right? Yesterday's is not binary searchable. Today it is, because a threshold you can go under the threshold by a lot, right? So so having more cells, and there's no negative numbers, by the way. Having more cells just means that it'll get closer to the threshold for the most part. I mean, it could be zeros, I know, but yeah. Okay, so then now we have prefix of I plus target, j plus target, minus prefix I plus target, j, minus prefix I, j plus target, plus prefix ij, right? So if this is less than or equal to threshold, then we return true. Otherwise, we return false, and we are less happy. Okay, looks okay. Let's give a quick submit. Hopefully I didn't make a silly mistake. Yeah, I mean, sometimes, you know, sometimes even Larry gets it right without making a mistake, which is nice. And that's it. Yeah, this is going to be O of log or C, which is log of 300, which is what, like less than 10, right? 10 is 1024, so like that's like 9, which like 9 or 8, which tells you how quickly binary search scales, right? Because you know, I just guessed 1,000, and it's already like, you know, just two more iterations, and you're already going from 300 to 1,000. So, but yeah, and then of course every loop, every of those log 300 loop, every 8 loop, we do have an R times C linear thing. So this is gonna be n log n-ish, if you want to say, and that's basically the idea. I say log n because you could say it's log of R plus C, and R plus C is O of n-ish. Maybe you could say maybe square root of n, I don't know, right? But square root of, or log of square root of n is still log n, right? You know, if you just do the math on the basis. So it's going to be n log n. And n, of course, is R times C, by the way, right? And that's it. That's all I have with this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to mental health. Hope y'all have a great rest of the weekend, whether you get it off or not. I'll see y'all later, and take care. Bye-bye.